Okay, so today we're going to continue with our feasible region. So now I give you this equation and we're going to find the feasible region for this equation. So as I mentioned before, so what we're going to do is we're going to find out something like this. So let your 3x minus 2y equivalent to 6. So when x equivalent to 0, my y equal to negative 3, and my y equivalent to 0, my x equivalent to 2. Okay, so I'm going to draw a straight line. Since it has the equal symbol here, so it's going to be a straight line. So here is negative 3 and here will be 2. So this is the equation for 3x minus 2y equivalent to 6. We don't need to modify any equation. We don't need to bring like a y equivalent to what. No need. We just write down whatever is here. We just write down. But instead of the inequality symbol, we put equal symbol. That's all. Okay. So now we're going for the second equation. So the same process goes on. So let x minus 3y equivalent to 9. So when x equivalent to 0, my y equal to negative 3. When my y equivalent to 0, my x equivalent to 9. But since here is the greater than only, there is no any equal symbol. So what we're going to do is we're going to have a dotted line. So 9, and this equation is x minus 3y equivalent to 9. Okay. Okay, so now we're going to find the feasible region. Where does the regions fall, the shaded region? Okay, so for that what we have to do is we have to rearrange the equations first, because by having something like this, it's very difficult for us to identify whether it's going to be above the line or below the line. So what we do, we will make it y as a subject. Means y equal to something, y equal to what? Okay, so we will do something like that. So it's going to be 3x minus 2y less or equal to 6. So negative 2y less or equal to negative 3x plus 6. Okay, and then whenever you multiply or divide with a negative number, for example here y, so you're going to bring this negative to our right hand side, so you're going to divide with a negative number, so it's going to be change the symbol, so it's going to be 3 over 2x minus 3. Okay, so it's going to be greater than, means it's going to be above the line. So this is the equation for this, so it's going to be above the line. Okay, this is our first equation, and then for the second equation, it's going to be something like this. For example, x minus 3y greater than 9, so you rearrange 3y negative x plus 9, so y less than 1 over 3x minus 3. So it is less than, so this is the line for this particular equation. So less than means it's going to be below. So it's going to be below, so it's going to be here somewhere. Okay, so if you notice here, only this particular region, okay, having both line intersect. So here is the only place where the both line intersect, means this is your feasible region. Okay, so maybe we redraw the graph in a proper way. So we're going to redraw the graph. Since it's not wrong. So here just now is 9 to negative 3, and this equation is 3x minus 2y equal to 6, and for this is x minus 3y equal to 9. And just now the feasible region is going to be, so here is your feasible region. Okay, if you notice just now we have only one equation, so we have only one feasible region. Okay, when we have two equation means the feasible region will be the region where it satisfies both the equation. Okay, it must be satisfied by the both equation, then we call that as a feasible region. Let's say what happens if we have three equation. For example, let's say I give you three equation. So for example, x greater or equal to 0, y greater or equal to 0, x plus y less than or equal to 2. Okay, so for these two we don't need to draw any graph because it's already the axis. Okay, so for this it's going to be when x equal to 0, my y equal to 2, y equal to 0, x equal to 2. So we can draw, since it has equal symbol, so I just put the straight line, 2, 2, so x plus y equal to 2. Okay, so first when I said x greater than 0, so my feasible region is going to be here. When x greater than 0, because this is x equal to 0, this line is x equal to 0, so greater than 0 is going to be this line, the first one, and then y greater than 0 is going to be, this is the y equal to 0, so greater than 0 is going to be here, okay, and then for this is going to be y less than or equal to negative x plus 2. So y less than x negative x plus 2, so this is the equation, so it's going to be below this line, so it's going to be here. If you notice, the all three regions intersect or satisfy is this. So here it only have 1, 2, so the first line and the second line, here the first line, second line, here the first line, second line. So if you notice, all these places we have only 2 lines, whereas here we have 1, 2 and 3. There are 3 lines. So within this region we have 3 lines, means this is the feasible region which satisfy all 3 constraints. So this we call as a constraint. So we just redraw in a proper way, find the shaded region. So x plus y equivalent to 2, so this is going to be the region. Okay, so this is a feasible region for these 3 constraints. Okay, now what happens if I add another equation? I add one more equation for this. I want to be a 4 equations to be there. Let's say I give you another equation, y greater than 1, put 2x, greater than 2x. So similarly, we're going to draw this graph. So it's going to be y equal to 0. So we put x equal to 0. So we put x equal to 0, y equal to 0. So this is the point where there's the origin. And for another coordinate we put x equal to 1. So my y is going to be 2. So let's say x equal to 1, y equal to 2 is somewhere here. So since it is greater than only, there is no equal symbol, so it's going to dotted line. Okay, it's going to dotted line, so y equivalent to 2x. Since it is greater than, so the shaded region is going to be above the line. So this is the shaded region. Okay, therefore if you notice here, this is the only place where we have two lines together or intersect. So my final answer is going to be so 0, 2, 2. So this is equation for x plus y equal to 2, and this is equation for y equal to 2x, and y-axis and x-axis. Okay, so this we call as a feasible region. And then if I want to find the coordinates or corners of the feasible region, okay, corners of the feasible region, so I want to find the corners of feasible region. So corners of feasible region means what are the points on the feasible region places. For example, so this is one corner, this is the second corner, and this is the third corner. Means here I have three corners for this. Okay, so here we know the coordinate is 0, 0. Here we know the coordinate is 0, 2. And for this corner we are going to calculate. Okay, we are going to calculate. So since this is intersection between the first this line and this line, so we are going to find using these two. So for the first one, y equal to negative x plus 2, and second one y equal to 2x. So you can take this, substitute inside. So it's going to be 2x equal to negative x plus 2, so 3x equal to 2, so x equal to 2 over 3. When x equal to 2 over 3, my y is equivalent to 4 over 3. We just take this value, substitute here. So y equivalent to 2 over 3, so you get 4 over 3. Okay, so this coordinate will be 2 over 3, 4 over 3. Okay, therefore the corners of the the graph or the feasible region is going to be, there are three corners. The first one is 0, 0. The second one will be 0, 2, and then the third one will be 2 over 3, 4 over 3. So these are the three corners that we have for the feasible region. Okay, so with that, thank you. We will see you in next class.